All right, moving on to the second half. We're going to learn about cumulative distribution function or CDF. As I mentioned previously, CDF is the idea of is based off of the PDF. Okay, so have a look. So given a PDF function fx, okay, the idea is that so fx gives you a graph that looks something like this, right? This is f of x, yeah, and then this is the x value. So let's just say you have a graph that looks something like that, okay, and then it'll be like 0 afterwards. So what is the cumulative function distribution? What's the CDF or big F of x? So this is the notation for it will be big F of x. Remember how I said earlier that you can't use big F of x because it means something different? Yes, it means the cumulative distribution function, okay? The CDF is big F of x. So note that when you have a PDF, for example, fx would be like it will be a piecewise function, right? So I think I'll use one of the previous example, which would be, okay, so 3x squared for 0 to 1. Inclusive, okay. So 3x squared from 0 to 1 inclusive and then 0 otherwise. Right? So given a function like, given a PDF like that, the CDF or the big F of x will also need to be a piecewise function. Okay? But the piecewise function will be a little bit different. So let's say we will use that example from 0 to 1. So the graph will look something like 3, 1, that's from 0, that's 1. 3 times 1, it says 3, is something around here. Should be something like that, right? Okay? So that's the PDF. Now what's the CDF? The CDF is the idea that if you have up to a certain x value here, right? The area from the left all the way to that x value is the cumulative distribution function, CDF. Yeah? Okay? Now, what's the notation then? The notation will be big F of x would be whatever we can find, and it will be up to this x value, right? So the actual formula looks something like this. So big F of x is equals to antiderive from the left to, now this is key, an unknown value x, right? It must be a function, right? So ultimately there must be x inside it. So you're antideriving from the left, in this case 0, all the way to the value x, and then that is the of the function fx, and that is the cumulative distribution function, CDF. That's it. Right? So you guys have learned earlier that if this one is like m, that would be median, right? And then the area should be 0.5, for example. Right? So, and then when you antiderive to a, and then the area is 0.25, that's a lower quartile. Yeah? So remember, it was from like, let's say from the left, right, negative infinity to m equals to 0.5, that's the median. All right, that's to find the median. And then to find the lower quartile, antiderive from the left to a should be 0.25. And then the upper quartile, antiderive from the left to b equals to 0.25. So this is 0.75, right? So CDF takes that further, is to create an equation where the area to the left of a certain value is given by that equation. Okay, so let's say given the example of, let's say you'll give the example of big F of x. So I'll use that example over here. Okay, so big F of x is 0 otherwise. Otherwise, and it would be 3x squared from 0 to 1 inclusive. Now, how do we find big F of x then? Big F of x, right, would be antiderived from 0 to a value x, right? So from 0 to a value x of this function here, okay, dx, and that's it. This is literally just a formula for the CF, and we'll look at an interpretation after we've found it what it actually is. So when you antiderive that would just be x cubed, right, from 0 to x, yeah. And when you or actually, this one you might need to use a helping function. We need to go ft dt to avoid confusion. So it will be ft dt. Okay, so it's just like instead of writing x, you write t, right? So that is a different variable. So when you antiderive a function, then you need to be with respect to a variable inside the function. So the idea is that just use a different variable like t. Now t is a common one. So antiderive 0 to x, yeah, and from the left to x of function, but instead of x, you put t in it. Does it make sense so far? We'll give you an example. So at this point, it would be like antiderive the t would be t cubed, right? And now when you substitute the limits in x and 0, it's it makes a bit it is a bit less confusing. So it'll be x cubed and then minus 0, right? Which is just x cubed. Yeah. So what does that mean? So big F of x would be x cubed. So given this, right, you need to actually write big F of x in like a piecewise function. So then therefore big F of x would be, now this one is a little bit strange. It would be 0, right? If x is less than equals to 0. Because remember, the area to the left of the area to the left of a function would be 0, right? On the left side there, yeah, there's no area, right? So the area would be 0 when x is less than equals to 0, and then it would be x cubed, right? The thing that we just found, x cubed between the limits of the PDF between 0 and 1. See how this one then corresponds to this one here, right? Yeah. So for x between 0 and 1, the area to the left of any of those values would just be x cubed. And you need to say that the area equals to 1 for x greater than 1. And this is technically less than 0. Why? Why is that the case? If we were to sketch this, right? If we were to sketch this one out, x cubed. So what does the x cubed look like? From 0 to 1, it would just keep on rising up. So it would be something like this. The area is 0 to the left. Alright, the area is 0 to the left. Yeah, and x cubed, so it sort of raises up to the certain point here from 0 to 1. And after that, the area is always consistently 1. Okay, and the maximum is 1. Why is that the case? Why do you think it's the graph for the big F of x? This is the big F of x graph against x. Why do you think it's just fixed at 1 after the point 1 here?
X is equal to 1. Area is equal to 1.
Yes, the area is equals to 1, and for any point after this, so remember, if we were to draw that graph, the PDF, it goes up here, right? But then after that, it would be like 0, otherwise, like so. Right? And then before that, it would also be 0, like so. Right? So at a certain x point, let's say here, what's the area to the left of this point? Well, it will be the entire area of this function, which is 1, plus this bit area here, which is 0. Right? So that'll be 0 plus 1 plus 0, which is still 1. Does that make sense? Right? So for any x value after 1, in this case, right, after 1, the total area is everything to the left, which is everything, which is 1. Does that make sense? Yeah. So that brings me to a important property of the big F of x. So this one is a non-decreasing function. Okay, what does that mean? It means that for a big F of x function, right, generally it will always start from 0. Okay, it will start from 0 and then it will keep on rising whatever way it wants, and then it has to get close to 1 or be exactly equals to 1 at some point. And at the point where it becomes exactly equals to 1, after that it will just be a straight line. Yeah, because it's the CDF is the area to the left of a certain value x. Remember, that's the area to the left. Yeah, so that is also equals to, so the notation is, so this one would also be, okay, I'll use this one here. This one also be equals to probability, the probability of x is less than a certain value x. And what's the area to the left? Does it make sense? Think about it, okay?
Yeah.
It makes sense? Yeah? Okay, for Suleiman and Emily, if you guys are listening to the recording up to this point, if you need to pause it, go back to the notes and think about the concept of big f of x, yeah? I'll upload the digital version as well, so make sure you refer to that, because if you get it, the questions will be very easy to do. So once you understand a CDF function, applying it is really easy, right? But understanding it is the hardest part of the CDF concept. Okay, all right. So I'll actually use a few examples. I'll go through all of the examples from the textbook. Hopefully that will make things a bit easier. Okay, let's see. Skip this one, 19E. Okay, so first example 14. Okay, all right. The time, x seconds, that it takes for a student to complete the puzzle in the random variable, yada yada. It's just giving you the PDF and then find big f of x, the cumulative distribution function. So once you get the idea, applying it is very easy. Big f of x is equals to n to the right from, and this is x more than 5, right? So n to the right from 5 all the way to an unknown value x, right? And remember, the part next after that is ft dt. Yeah, so we use the function 5 on x squared, but instead of writing x, you would write t. So then that would be 5 over t squared dt. Make sense? Yeah, just to change x into a different variable so we can anti-derive and not having to worry about that. What's the x there? So after that, it's just applying it. So that would be from 5 to x, and then that would be 5t to the power negative 2 dt. Right, add 1 to the power, divide by the new power, that would be negative 5 t to the power minus 1. From 5 to x. Sub in the values, that will be negative 5x to the power negative 1, and then minus is a plus 5 times 5 to the power minus 1. Right? So then that would be negative 5 over x, and then plus 5 on 5, which is 1. Yeah? And then we can rearrange it, that would be equals to 1 minus 5 over x. Does it make sense?
Why is it x and 5?
Why is it x and 5? So this PDF, it will, if we were to sketch this, right, at the value 5, before that it will be 0. Okay, here it will be 0 before that, and after that it will, at 5, it will start from 5 over 5, because that's 1 over 5, which is 0.2. Okay, so it will start from here, and then it will keep on going like that. Right, so this is the graph of this PDF, and at a certain, so they're saying that I want a function. What I want is a function to calculate the area to the left of an unknown x value. Okay, so given this unknown x value there, how can I have a function to just easily calculate the area to the left of that x value? So that's why in this case, it starts from 5, it goes to x. Right, and that would give you the, if you calculate that, that would give you the CDF, the cumulative distribution function. So the area to the left of a certain x value in this PDF example. Does it make sense? Yeah. So from the left to an x value, right? Because we're not defining what that x value is. So remember previously, if we define it as m, then that's a median. We know the area is 0.5. If we define it as a, then we know that's the lower quartile. The area is 0.25. But we call that x because we're not trying to find a value, we're trying to find a function, right? The final result is a function. Okay, you see this one, f big f of x, this is a function, right? It's not an answer, it's not like 0 point something, it's not 2, it's not 3, no, it's a function of x, right? So that's why it's big f of x, right? That's a function of x, and that's why the n limit is x, to have, so that you have that variable x in the final answer. Okay, so yeah, if we continue with this one here, yeah, so see, this is the big f of x at this point, right? And then how do we write the notation again? So looking back at the PDF, right, the area to the left of 5 is what? What's the area to the left of 5? Of the initial part. What's the area to the left?
0.
0, that's right. okay? And then there is no upper limit, right? Because as long as x is more than 5, the PDF has this structure here, okay? That means that to write the proper PDF, big F of x would be 0 when x is less than 5. Okay, is it inclusive? No. So 0 when x is less than 5, and the area will be 1 minus 5 over x when x is more than or equals to 5. Okay, so this is the way to find the big F of x for question A. Now that we've got the big F of x, the cumulative distribution function, the CDF, we can easily do question B. I'll show you. Question B1. B1, probability of x less than equals to 7. Wait for it, is simply big F of 7. Does that make sense? Nah, this jump is the biggest jump. Doesn't make sense, right? Okay. All right. Let's visualize this. Okay. So I'll do a bit of visualization here. So probability of x less than or equals to 7. Once again, I'll draw that graph here. 5 and this is, let's say 7, right? Yeah. So 5 is start from 0.2 up here and then it goes down. So that's the graph, and the area and that will be 0 onward. So the area from 5 to probability x less than 7 is the area from 5 to 7, right? Make sense so far? Yeah. So technically, this one would be anti-derived from 5 to 7 of the PDF fx dx, right? Make sense so far? Yeah. It's just the area to the left of 7. Now, note how did we calculate the big F notation? Big F, okay? So remember, big F of x is equal to anti-derived from 5 to an unknown x. In this case, we know the unknown is 7. Right? And then this one will be ft/dt, but it's just a different variable. But basically, it's the same thing. Right? This ft/dt and fx/dx is referring to the same function. In this case, it would be the 5 over x squared. Right? So there would be 5 over t squared dt, and this would be 5 over x squared dx. Okay? So you see, the only thing that is different is in the big F of x, you get an x variable. And then in the actual probability, you get 7. So you see, the only difference is this. So this one, right? This is probability of x less than 7, right? That means if I look closely at this section here, so this is the section, right? This is the area to the left of 7, right? Yeah? And what I'm saying is the CDF, or the cumulative distribution function, big F of x, instead of writing 7, I'll put that as x. And so instead of 7 here, it's a probability that of x less than any certain value x. That's how you calculate the CDF. Yeah? And this is the definition of the CDF. Right? And that's why if you ask for the area to the left of 7, that just means, you know, you're changing this number to 7, which means this is big F of 7, done. Does that make sense?
Yeah.
Yeah? Because this is technically area, so think of it as area to the left of 7. Right? Area to the left of 7 is probability of x less than or equals to 7, and that is also the same as the definition of big F. That's why it's big F of 7. Does that make sense, huh? Yeah, big F of x is the area to the left of a certain x value. Right? And if they ask you, oh, what's the area to the left of 7? Then that value is just 7. Okay? Which means that, so now that with all that explanation, that would just simply be big F of 7. And what do we get? 1 minus 5 on x, so that would just be 1 minus 5 on 7, the answer 2 on 7. See, if you know what to do with the big F, if you understand the concept, it's like 1, 2, 3, 4 lines of work done. Okay, once you've got the big F of x, in some questions, they will tell you big F of x, and you just need to interpret it and get the answer. Okay, does it make a bit more sense?
Yeah.
Okay, next one. Next one is probability of x is more than or equals to 6. I'll tell you the answer first. This would be the same as, I will leave some space for explanation. This is 1 minus big F of 6. Does it make sense?
Yeah.
Make sense? Yeah? So the explanation is, so this would be, so nominally, this would be area right, area right of 6, right? Which means this is the same as equals to 1 minus area left of 6, right? And area to the left of 6 is the definition of big F. It's just big F of 6, right? So big F is the area to the left of a certain x value. Maybe I should write it up here somewhere. Okay. So big F of x, right, is equals to, or maybe I'll write this one here. Let me move this down a bit. Okay, so this is the area left of x. Okay, it's very important. Big F of x is the area to the left of a value x. Okay. Alright, moving on. So yeah, so that would be 1 minus area left of 6, which is 1 minus big F of 6, which is 1 minus 5 on 6. Alright, opening brackets, 1 minus 1 plus 5 on 6. The answer is 5 on 6. See, algebra pretty easy. Alright, if you understand what a big F notation means. Make sense? Yeah? Okay. This is a bit tricky, but if you get it, you get it. If you don't get it, it will take some time to actually get it. Now, the third example, B3. Alright, so B3, probability of 10 less than equals x less than equals 20. So how? What do you think in the big F notation, what would this be? Give you a hint. Alright, look at the graph. So same thing, so like that, and then this is 10, and then this is 20, all right, and the graph keeps on going, and this is 5 here, all right, so we want the area between 10 and 20. How do you relate it as in the case of area to the left of something? So hint, this area from here to here, that's big F of 10, right? And then the area from here all the way to the left would be big F of 20. How do we find this probability?
So the big F of 20 less than or equal to x less than or equal to 10?
Not quite. Big F is a cumulative distribution function. You just put a value in it.
Just 20.
Yeah. Only when you see probability is when you have a condition, right? If it's like fx, if it's like fx or big F of x, then you just sub a value in. Okay? So in this case, big F of x, you just need to sub the value 20 in, and what do you do next? So remember, big F of 10 is the area to the left of 10, big F of 20 is the area to the left of 20. So you need to use these values to calculate, probability, so the area between 10 and 20.
You find F of 20, then minus F of 10.
Yes, that's right. That's it. Make sense? Yeah? So nominally this is area left of 20 minus area left of 10. Yeah, that's it. Alright? So area left of 20 is that whole section there, the whole section in blue there. And then area left of 10 is the whole section in gray. Wait, hang on. I can change this on that. Yeah, this one will be the whole section in gray. It's a bit hard to see. But yeah, it looks something like that, right? So that would be the area from 10 to 20. So yeah, so f of 20, it's just sub the value 20 into the big F of x function. Right? Pretty easy at this point. So that would be 1 minus 5 on 20 minus brackets 1 minus 5 on 10. Right? Algebra super easy. It's like 4 lines, every single 4 or 5 lines for every single question. Just knowing what to apply, it's probably the hardest part. Okay, so then that would be 5 over 10 minus 5 on 20, because the other one get cancelled out. So that would be 10 out of 20 minus 5 out of 20. The answer would be 5 out of 20 or 1 over 4. Okay? If you were to calculate, so this is optional, but if you were to calculate antiderive from 10 to 20 of the function, which is 5 on x squared dx, it will be the same thing. Okay? Yeah? Okay, alright, so that's the first example for the big F notation. So that's the example where we have to find the big F and then we'll use that to calculate. We'll go through one more example. This time we're just using the big F notation. Okay, we don't have to find it. They give us the big F notation and then we need to use it somehow. Okay, example 15. Alright, have a look at this one. Okay, so this one is a little bit different. They are not asking us for probability. They are asking us for the PDF. So note that they give us the CDF and then they ask for the PDF. Alright, that's the CDF. Okay? So do you remember how do we find the CDF? What's the formula? What's the formula again for big F of x? Area to the left of a certain value x?
Yeah.
Area means antiderive. To the left means it starts from
1.
Negative infinity.
Oh yeah.
Yeah. To the left of a value x means it ends at a value x.
Oh yeah.
Yeah. Okay. And then the function is changed into
1 minus e negative x squared.
almost. The formula is ft dt. So when you apply it, it will be so okay, in this case this is the CDF. Yeah, this is already the answer. All right, so this is the formula. So if ft is the PDF, this one here is the PDF, right?
Yeah.
Okay, if you antiderive to get the CDF, how do we find the PDF?
You derive.
Yes, that's right. Derive the CDF, that's it. You do the opposite. Okay, so then when you derive d over dx of 1 minus e to the power minus x squared, 1 becomes 0, then that derive the power times it down, it will be 2x e to the power minus x squared. Looks familiar? Yeah, it's the last one, isn't it? Okay, but yeah, anyway, so that would be your so this is the derivative, but you need to write the PDF properly. So PDF, how do we write that? We need to start with f of x, and remember the CDF is a piecewise function, so the PDF is also a piecewise function. So what do you think? How do you think we define the PDF? What's the first limit? So one of them would have this equation that we just found, right?
Yeah.
Yeah, and what's the limit for that? When would that be the PDF? For which x values?
Is it less than 0? Or is it more than or equal to 0?
More than or equals to 0. You look at where the domain for the CDF is, and that would be x is more than or equals to 0. And when x is less than 0, what's the value for the PDF?
0.
0, that's right. Okay, so that's the official way to write the answer for PDF. Okay, does that make sense? Yeah, so the only thing that you need to remember is the formula. There's only one formula, technically, right? Technically, this is the only formula in this chapter that you have to remember. But understanding this formula is, yeah, it's a big thing. If you get it though, when a question comes out, and pretty sure there will be a question like this in the exam. Most likely, it's a tech-free question because the answer is so simple, but it tests so many things. You have to understand what a PDF is, what a CDF is, and then understand what the question is talking about. Later on, you might even see a conditional probability at some point. Yeah, you might even see a conditional probability at some point, and then you have to apply the CDF. If you know how to use it, it's really easy. But if you don't know how to use it, you struggle and you don't even know where to start. Okay, so that's why this chapter is one of the most interesting one, where either you get it or you don't. You get it, you are guaranteed to get some marks in the exam. If you don't, you are guaranteed to lose some marks in the exam. Almost always come out in the past, regardless of what exam or what school. Okay, all right. Time for you to actually do some practice. Question 1. All right. So for question 1, I will help you out a little bit by writing the formula here. Just writing the starting bit, and then I'll give you some time to work on it before I go through. I start working through the answer. Okay, so that's the scaffolding for question 1. All right, knowing how to write that will also instantly give you like 1 mark or so in the exam. I'll start working through this one now. And the answer for B is actually very, very simple. So you can also finish B by yourself. So make sure you write this CDF, the big F of x, in a piecewise function at the very end, yeah, before moving on to question B. Because if PDF is a piecewise, then CDF is also a piecewise. Yeah, so how does it make sense, this part there? The condition for CDF, the 0 and 1. Do those two parts make sense? 0 when x is less than or equals to 0, and then 1 when x is more than 5.
Yeah.
Yeah? Yeah, because when for the PDF, when it's after 5, the PDF is 0. But so this PDF, okay, actually maybe I'll interpret this one. So this one, right, it's a constant function from what at 1 over 5, which will look something like that. From 0 to 5, it is a constant function, right? And the constant function is at 1 over 5, right? So the area from the left to a certain value x, right? If you want to calculate that area, when you think about it, it's a rectangle, isn't it? Right? So the area would just be the width, which is 1 over 5, times by the length, which is x. Right? Given an unknown value x here. If the x will be like 3, then it would just be 1 over 5 times 3. If it's x, then 1 over 5 times x. Right? X is an unknown length. Does that make sense? That's the area to the left. And so for any value after 5, let's say 6 for example, it already covers all of this area. So it should be 1, right? Because after 5, the function drops down to 0. And then before 0, the function starts at 0. Okay, so the function technically looks something like 0, and then 1 over 5, and then 0 again. Does it make sense? Yeah? So that's why when you get it, actually, this function here, big F of x, when you were to visualize that, it looks something like this. Before 0, it would be 0. Right? Before 0, it would be 0. And then after 5, and then after 5, it would just, so from 0 to 5, it is 1 over 5 times x, right? So it just goes up like that. And then the maximum is 1. The maximum area is 1, and after that, it will just continue to be 1. Right? This is the big F of x graph. Does that make sense? Mm-hmm. Yeah? Because after the x value of 5, and the x the x-axis is just x. Okay? So after you've already covered all the area to the left of the function, then it should just be 1. It can't get more than 1. Because remember, the area represents the probability, right? And probability cannot exceed 100%, right? And that's why the maximum is 1 after the maximum limit. Make sense?
Yeah.
Okay, did you get 3 over 5 for question B?
Yeah.
Yeah, okay, good. So yeah, so question 1 is the easiest one. Now let's see. Okay. Now we'll look at some application ones. Let's have a look at question 3. Okay, have a look at question 3. So sketch the graph of this. How do we sketch this one? Well, actually, hang on, x1 and 0. Okay, you don't need to worry too much about sketching this. I'll just give you the answer for A. Just focus on B and C. So sketch this graph. When you put it into the calculator, it will look something like this. Big F will be 0. Minus 1 is 0. So it starts something like that. Right, at 0, and when it's more than that, it will just keep rising. And it approaches the asymptote, which is big F of x equals to 1. It will never be equal to that because it will just keep on going forever. But remember, the one that will deal with infinity, the total area towards infinity will tend to approach 1. And that's why it's still a PDF. So yeah, so this is the CDF function for this graph. It looks something like that. And then before that, it will just be 0. It will just be 0 before, and then it curves up towards the line after 0. Alright, try question B and C. Give you some time to think about it.
Isn't B just subbing 2 into X?
B, no, not quite. It's not just sub 2 into X, you do sub it into X, but remember, big F is the area to the left of a value.
So it's from the left, but then yes, from X to 2. And then you just find the area from that.
So what would the function look like?
It would be 1 minus E negative 4.
No. Remember, when you sub 2 into big F, which is, you're talking about big F of 2, right?
Yeah.
This is the area left of 2. Right? This is area right of 2. Right? Because more than equals to 2. Yeah? Which means this is 2, right? And then more than equals to 2. That's the area to the right of 2. So what would that be? Using the big F notation. Remember, you know the total box area, and then you want area to the left is...
Is it?
So big F of 2 is the area to the left of 2,
Yeah.
and you want the area to the right of 2. So how do you
isn't
find?
it the total area minus?
Yeah, what's the total area?
1.
Yeah. Yes.
It's 1 minus that function.
Yes, it's 1 minus big F of 2. Make sense? Now you should need to work it out. Okay, so for question C, this would be PR of, basically just and the 2, so intersection, over PR of x less than 3. Now the trick is, you gotta interpret this.
You find X less than 3 first. Or
No, you have to do the intersection. Right, remember the intersection? You need to use the number line.
So isn't it everything below 2 and below?
Work it out. Work it out. Use the number line. See what the resolve condition is.
Isn't it 2 then? X is less than or equal to 2 on the top.
That, yeah, what was it? So
X is less than or equal to 2.
no, the overlapping.
Oh wait, that's greater. Oh, so it's overlapping. X is greater.
So what is the resolved condition? Right, I drew a little diagram there, showing two lines and the intersection between them. So what's the resolved condition?
2 greater than or equal to
No, 2 less than or equals to.
sorry, less than or equal to x, less than or equal to
Less than only. Remember, be very
okay.
careful. This one is hollow. This one is solid. Yeah, because they say x less than 3, right? Yeah, so one of them must be hollow. The other one is x is more than equals to 2, so it'll be a solid dot. And you have to resolve the condition correctly using the. So it'll be less than 3. Okay? Alright, now use the big F notation. How do we use this big F notation to solve this one? How do you find the area between 2 and 3 using the big F notation?
f of 3 minus f of 2.
Yes, that's right. Very good. That's area to the left of 3 minus area to the left of 2. Yeah, because big F is the area to the left of something, right? And then the bottom is just area to the left of 3, so it's just big F of 3. Okay, and then the rest is just algebra. Work that out. Punch it in, see if you can get the same answer. Okay, next is question 4. Now try this by yourself, and you can ask me questions if you want, but I won't give you the answer straight away. See if you can think and find a way to figure out question 4a. I'm sure you can do 4b, but 4a. Remember, this is the CDF, aka area to the left of a value. So, how do you think we should do question A? Very good. So the idea is that this is supposed to be a CDF, right? And the idea is area left of 6, which is the upper limit, must be equals to 1. And to translate that to big F notation, that's big F of 6 equals 1. And that means you sub 6 into x, let that equals 1, solve for k.
1 over 36.
Yeah, 1 over 36. So k times 6 squared equals 1. K is 1 over 6 squared, which is 1 over 36. Very good. And then you can do question B.
Is it f of 6 minus f of 1 over 2?
No. On the right track, but think about the limits carefully. What limits are we looking at here?
1 over 2 and 1.
Yeah. So it's the area between 1 over 2 and 1. Okay, so using big F notation, what would that be like?
F of 1 minus f of 1 over 2.
Yes, that's right. All right, keep going. Did you get this part here?
Yeah.
Yeah. Do you know what I did there?
You took out
Yep.
1 over 36.
Yep.
If you were to do it normally, then it would just be 1 over 36 minus 1 over 144.
Yeah, it would be, yes. And then you would times the other side by 4. So on the normal way, that would be 4 over 144 minus 1 over 144.
Which is 3 over 144.
Yes, and then you should have to divide by 3.
And 1 over 48.
Yeah. So the answer would be the same, you just have to deal with bigger numbers and recognizing that 144 is divisible by 3. So yeah, that's why I tend to take out common factors when you are doing the addition and subtraction, especially subtraction, because sometimes it makes the number easier to work with, and then it's a bit easier to see the simplification as smaller factors. Okay, 1 over 48. All right, next question. We'll keep going. Each question is a little bit different. So that was 4. Now, next one is a little bit different. Question 5. See if you can once again apply the PDF to solve these concepts here. Again, once you get the idea that CDF is the area to the left of a value, yeah, these questions are actually not too hard. The algebra is pretty easy. All right, try question 5.
How do you do median again?
Median is the number where area to the left of that is.
In the middle? Is it halfway?
It's half. Well, it's technically not halfway, but it's the number where area to the left equals to
1 2, half.
a half, yes, or 0.5. Alright, so area to the left of the median is 0.5. That's a hint for question B. Question A is pretty simple.
Oh, so then I would make it equal to 0.5.
Yes.
When doing QR, since it's already CDF, would you just sum in the value straight away?
What value?
Oh, 0 and 8.
You will be subbing in A and B, and then you let the area equal to something.
0.25 and 0.75.
Yeah, and then find A and B.
But you wouldn't anti-derive though?
No, there's no anti-derive.
It's already
yeah,
okay.
yeah. See, if you understand big F, it's so much easier to actually do these questions. And actually, if you guys can do this concept well, there is a way to very quickly do the PDF question by finding the CDF first. Yeah, this is one of the shorter way of doing it. It's like the big G notation. Remember I told you guys earlier, like you have to find an antiderivative big G and stuff like that. Yeah, so the proper way to do it is using the CDF. That's a proper way. A over 3?
My A was 40.
Your A should be 40 over 3. Alright, area to the left of A is 0.25. So big F of A equals 0.25. So you sub A into big F of X and the answer should be 0.25, which is 1 over 4.
I did minus the 1 from both sides, so I made it negative 10 over A is equal to negative 0.25.
Alright, negative 10 over A equals to negative 0.75.
Because you're minusing 1, yeah.
Yes.
Which is, that's 13.33.
It's the same.
Oh, so I just swapped the other
Yeah,
one.
but you keep it as a fraction, so 40 over 3.
So 40 over 3, yeah.
Okay, did you get it? A over 3? Okay, alright. Next question is to find the PDF given the CDF. So this one is not supposed to be difficult, but the tricky part is to know how to write the PDF in the piecewise function form. So that's the one that you need to practice. Alright, try this one. Shouldn't be too difficult. So you start with deriving this thing.
Yeah. Wait, so would there be, when you derive it, is there going to be 3 things or 2 things?
2 things. Because derive, you go down.
Yeah.
When you anti-derive, there's an unknown constant. Alright, but when you derive, it's just derive as usual.
So then it would be 0 is x is less than 0 and 12x squared minus 12x to the power of 3 is 0. Less than or equal to x, less than or equal to 1.
And? Okay, here. This, so I'll work this one out. It's like a one-liner thing. But, so normally for the PDF, you would write the main one first. So 12x squared minus 12x cubed, right? And then that's for 0 less than equals x less than equals to 1, right? And then the trick is to write 0 otherwise. Yeah, so the condition is just otherwise. Like if x is outside of that range, it will just be 0. Okay, so writing the PDF is a lot easier than writing the CDF. Does that make sense? Because CDF you need to remember the start and then the end. Alright, and then the main CDF will be like in the middle. Okay, the start and the end is a little bit different for the CDF, but PDF, if you just get the main function, write the main function with the domain and 0 otherwise. I think they will mostly accept that. If you want to be strict about it, technically you can write, instead of otherwise, you can write x less than 0 or x more than 1. Does it make sense? Yeah, because that's outside of the domain of the function. Alright, so it's just that for the CDF, if it's more than the maximum, the area is 1. Alright, but for the PDF, it's just still 0. It's just like it will go from to 0, and then from 1 onwards, it's also 0, and whatever can happen in between here. Yeah, so this is for the PDF. That make sense? Yeah, it's just that for the CDF, it will start from 0 still, and then it will strictly increasing function, but then after that, it will stay at 1. This is the CDF. Yeah, you see the difference? Yeah? Okay. So yes, that's question 6. Now I think I'll give you some extra practice on finding the CDF rule, because I don't think there's enough practice in the textbook. So let's try this. Find CDF for the following function. So question A, small f of x is equals to x over 2, and this is a special question, yeah? Yeah, let's say extra question 1. Fx would be x over 2 for 0 less than equals x less than 2 and 0 otherwise. Okay, right, try this one, extra question 1. Find me the CDF for this equation here.
Oh, but you're not subbing the values in, are you? You don't sub the values in.
No, so the big F of x is anti-derived from the left to a value x of ft dt. Maybe it's worth to just write the formula every time before you actually solve it. Alright, so it's to the left of x, and then that will be t over 2 dt. Like so.
So isn't it just 1 over 4x squared?
Yeah. So that would be, 1 over 4x squared, yes. So 1 over 4 t squared, and then from 0 to x, which is essentially, yes, you're right, 1 over 4x squared. Now, write the final notation for big F of x. So be very careful with the symbols, yeah? The symbol has to be 100% correct. Okay, did you get that?
Yeah.
Be very careful, yeah? It must be more than equals to 2 at the end, yeah?
More than equals to, yeah.
More than, that's less than equals to 2. Because it went from 0 to 2, the function applies. But when it's more than 2,
oh,
right?
Yeah, that actually makes more sense.
Yeah, so every single symbol has to be 100% correct. Okay, next one, let's try another one. So extra question 2, same thing. Find me a CDF for the following PDF. Okay. See if you can work. Actually, I should give a standard one first and then give you this extra one. Okay, go. Same thing, but this time the fx is a little bit different. See if you can figure out how to handle something like this. So there is no zero. It is a PDF that has two functions on two different domains.
So is it two different piecewise functions or just one?
The answer will be one piecewise function. The hint is you will have to antiderive twice. So there are two scenarios, right? The first one, the big f of x, is when x is less than or equals to 0, and the other one is for x is more than 0. That's a little tricky. So you have to consider. So I'll have a look. I'll give you scaffolding. There are two different conditions, and you do interact twice in parallel. Okay, that's a scaffolding. Work on that. Did you get the left hand side? Antiderive from negative infinity to x?
No.
No? Because for when x is less than or equals to 0, right? So this function, it looks something like this. At 0, after that, it will look like that, and then before that, it looks like that. So the area to the left from negative infinity to a value x, that would be the CDF for the function to the left of 0, right? Okay, so see, that's a tricky part when you need to antiderive from negative infinity. There are two ways of doing this. There's an easier way and there's a standard way. So remember how to antiderive from infinity? Lim, yes, correct. That's a standard way. So I'll show you the standard way. Okay, make sense so far? Yeah. Now, what happens when a goes to negative infinity?
Your number becomes 0.
Yes, that's right. Yeah. So that one will approach 0, right? Will approach 0 as a goes to negative infinity because it will be 1 over, right? So 0.5 times 1 over e power a really big number. So that will go close to 0. So that would just be 0.5 e to the power x. Okay? Yeah? Because it will be minus 0. Does that make sense? So then, write the final statement. We've got a final statement.
So how many things would it be? It would be just 2?
Just 2, yes. Okay, the right hand side is a little bit different. Okay.
Wait, can you write it as in fraction?
Yeah, you can. Yeah, 1/2. Yeah. But note that for x is more than 0, when you anti-derive this bit, this is giving you the area from, remember, from 0 to a certain x value, right? So from 0 to a certain x value here, right? But what does the CDF actually mean? This is a bit advanced. The CDF, let's just say an x value is like here, right? The CDF is actually the area to the left of this for the entire function. Does it make sense? Yeah? Because it must be all the way to the left, which means this is not the only part. So most students make the mistake of writing, oh, this would just be the same, right? It would just be 0.5 minus 0.5 e to the power minus x for x is more than 0. Wrong. Because that doesn't cover all of the area. That only covers this bit here up to a certain value x. How about that bit there? Alright, so the area to the left of x, remember the definition of CDF, area to the left of that value x must cover the entire area, right? The entire area before 0. And what do you think that area is? And how do we calculate the entire area before 0? Alright, so this one would technically be that, and then
Minus the other one. Was it all plus?
Plus, right? Plus area left of 0. And that would technically be anti-derived from negative infinity to 0 of the other function, 0.5 e to the power x. Alright? So you can do that. You can work out the answer. But when you really think about it, what kind of functions are these? These are exponential, right? They're exponential functions, and they are reflections of each other. Does that make sense? The only difference is this is power x, this is power minus x. It's reflected in the y-axis, yes. Which means the area to the left of 0 and the area to the right of 0 would be
the same.
The same.
Just one's negative, one's positive. Wait.
Yes, one is the negative, x, one is positive x. So that means that this area, so this requires a bit of reasoning. This area is equals to 0.5, and this area is also 0.5. Does it make sense? Because the total area is 1, right? And it's just reflection, right? So when you chop in the middle, each area is 0.5, which means that this whole thing, when you calculate it, it would be 0.5, right? If you were to actually calculate it, that would be lim of a to infinity of anti-deriving from a to 0, right? So that from a to 0, so that would be 0.5 e to the power x a to 0. So that would be 1. So that would be lim of a to infinity of 0.5 e power 0 minus 0.5 to negative infinity times e to the power a. And once again, this one becomes 0, so that will just be 0.5 times 1, which is 0.5. Yeah, so if you actually work that out, it will still be 0.5, but we can reason that out to be 0.5, so the answer would just be that plus 0.5. Okay, for x is less than 0, x is x is more than 0. This is less than or equals to 0. Okay, does it make sense? Yeah, and this one is the area left of 0 because it's outside of the main domain of the domain for the second function. Okay, I think I'll touch on this a little bit, probably either next week or the week after when Emily is back, and Suleiman will be here as well. But yeah, otherwise that will be it for 16E. Right, do a bit of revision next week, and then we'll move on.